Hi, my name is Erin Rose McNulty, and I will be doing my presentation on Newton's method. I am taking Calculus 1 this semester because I desire to have a strong foundation in mathematics for my future career in science. I have decided to research Newton's method due to its interesting history of development, as well as its ability to give close approximations of f of 0, which is very hard to prove, if not impossible. The history and development of Newton's method. Newton's method, also known as the Newton-Raphson method, was published in 1685. When discussing Joseph Raphson and his contribution to the method, he overlooked Newton's theory to ensure its validity and continue its research, later publishing it. When developing the theory, Newton solely applied the method to polynomials, beginning with an initial root estimate, creating a list of errors. He was then able to solve the problem in order to have an understanding of the issue. Overview. With f of 0 being close to impossible to prove, approximation of points close to 0 is critical. Tangent lines are used against the curve to provide close approximations of the points. After x2, you can continue to refine approximations until satisfied with the provided answer. Example 1. The first step of Newton's method is to find the derivative. In this problem, the original equation says x to the third plus x plus 2 equals 0. The derivative is therefore 3x squared plus 1. Next, we are able to substitute in -1 as x to get x2. We therefore can continue on to our third approximation, where we again will enter in -1 as x. Attached is the graph of this problem, where we can see the tangent line intersecting with our equation at -1. Example 2. Again, we will use step 1 to find the derivative, which in this case will be -3x squared minus 2x sine x squared plus 3. Using the formula, we are going to substitute the value of x1, which just so happens to be 2. After we substitute in 2, we will find that the answer is approximately 1.4388. We will then plug that number in again to get the third approximation, which will give us approximately 0.6911. Conclusion. Newton's method gives a close approximation of f of 0 by using points close to 0 to determine a close to accurate point. Tangent lines are used against the curve of the graph to determine the points of the value. Newton's method is a technique for solving equations of the form f of x equals 0 by successive approximation. These are the sources that I used to gather information to complete this presentation. Thank you for watching.